So in this question, one object is there. This mass is 0.5 kg and its velocity in this direction is 12 meter per second, and it strikes the wall here, and after striking, the contact time is 0.25 seconds, and after striking, it rebounds back along this path under symmetric condition. That is, this angle is 30, this is also 30, this mass is this, and u is again 12. Okay. So in this question, they are asking what is the average force on the wall. Average force on the wall. Okay. So time of contact is given. Time of contact given. So the very first thing that should come in your mind, that they are asking the force. Okay. And mass and velocity given. So with the help of mass and velocity, how can you find force? So remember Newton's second law, that is force equal to rate of change of momentum, that is delta P by delta T. Delta T is also given. This T is basically delta T for time of contact. Okay. So you need to find delta P, that is the change in momentum. Okay. So you see, look at here, if you convert this mass and velocity into momentum, so initial momentum is how much? This is P I equal to, suppose this is P1. So it will be m into u, that is how much? 12, it is 0.5 into 12, that means 6 Newton second. Any problem? This is 6 Newton second. Okay. So this is the initial momentum in this direction. Okay. And here also it is the final momentum. It is T2, and it is again 12.5 into 12 like this. It will be 6 Newton second. It will be 0.5 into 12, that is 6 Newton second. Any problem? Any problem? But the directions are different. This is along this direction. This is along this direction. Okay. So if the directions are different, this direction is neither along x-axis nor along y-axis. This is again neither along x-axis nor along y-axis, and momentum is a vector. Momentum is a vector quantity. Okay. So what to do when vector is not along x-axis or along y-axis? Then just resolve. Okay. So this is momentum P1, and to resolve this, you just resolve along this direction and along this direction. Okay. So if this angle is 30, so this will be 30. Is it okay? This is alternate interior angle. This is parallel to this. Any problem? So this is P1 cos 30. Any problem? And this is P1 sin 30. So what is this? P1 means how much? 6. And cos 30 is root 3 by 2. So it is ultimately 3 root 3 Newton second. This momentum. Okay, along y-axis it is this. And what is this? This is the P1. P1 is how much? 6, and sin 30 is
1 by 2.
So it is 3 Newton second. So along x-axis momentum is 3. Along y-axis, positive y-axis, it is 3 root 3 here. Okay. Any problem?
No, sir.
And here also, this vector is also neither along x-axis nor along y-axis. So you also again resolve this along y-axis, and along x-axis. It will be like this. Okay. So from tail it will be one vector, from tail it will be another vector. Any problem? So this is basically P2. So it is, if this angle is 30, then this angle will be 30. Any problem? This line parallel, this is transversal, this is equal to this corresponding angle. Any problem? So this will be P2, this is basically P2, So P2 cos 30, and this will be P2 sin 30. Any problem? So this will be P2 means how much? 6, and it is 1 by 2. That means 3 Newton second. And how much is? This is 6 into root 3 by 2. That means 3 root 3 Newton second. Any problem? Okay. So before striking this wall, x component, y component, no known initial condition, and after striking x component, x and y component known now. Okay. Just look at the board. So change in momentum, delta P, that is change in momentum, equal to P final minus P initial. Any problem? So P final is what? Along x-axis, after striking along x-axis, it is 3 in negative direction. 3 in negative direction. So it is 3 in negative direction. That is minus 3. And minus of, initially it is 3 in positive direction. So it is 3 in positive direction. So how much it is? Right, mod. So it is minus 6 mod, that is 6 Newton second. So change in momentum along x-axis is 6. Okay, any problem? So force along x-axis is how much? Delta P upon delta T. So delta P is 6 and delta T is this T is basically delta T. So it is this one, or 6 into 100 by 25. So this is 24 Newton. 24 Newton along x-axis. Any problem? So along y-axis, find the total change in momentum along y-axis. This is change in momentum along x-axis. So total change in momentum along y-axis will be again P final minus P initial. So it is 3 root 3 minus P initial. It is also along y-axis, 3 root 3. So it is 3 root 3, 3 root 3 mod. So it is 0. No change in momentum. So if no change in momentum, so force along y-axis will be how much? Delta P by delta T. So it is 0 upon time, that is 0.25. So it is 0. So no force is acting along y-axis. Only force is along x-axis, and that is 24 Newton. Okay. So the only force is along x-axis, that is force on wall F wall equal to how much? It will be 24 Newton. This should be the final answer. Any problem? Is it the correct option? Okay? Okay, fine. Stop it.